Okay, good afternoon. Hello, am I audible?
Yes, sir.
Okay, so can you see the slide?
Yes.
Okay, fine, very good. Okay, so actually, in the previous class, we were discussing about the testing, okay, different performance testing conducted on IC engine. So, for first one, we already discussed as most tests, and we have to discuss two more tests. And hope you understand. Do you get these answers? Hello, you didn't try it, right?
No, sir.
Yeah, okay, fine. There will be few more questions which will be forward to you. So you have to complete it in your tutorial note. Okay. So next we are going to discuss about the heat balance sheet. Okay. So do you ever heard about what is meant by balancing sheet? Balancing sheet.
No, sir.
No, actually, the balance sheet is nothing but for like if you are starting a business and everything, we will have a like for a month we will be we will be having it like we will try to understand what is the income and as well as the expenditure, right? Okay, for a particular firm there will be so many expenditure in the form of, for example, if you are like starting a shop, okay, a stationery shop, so there will be so many expenditure in the form of electricity, okay, as well as electricity, transportation, and for buying that particular goods, first of all we have to give the capital. Likewise there will be so many expenditure, right? Okay, then we will be calculating or we will be finding the income. Okay, so through that we will be getting a fair idea about whether this particular firm or company or this particular shop is giving profit or not. Understood?
Yes, sir.
Yes. Ndaro, are you okay?
No, sir.
Okay, fine, fine. Okay, so similarly, yeah, do you like then we can, if the profit is causing, then we will be like the break even analysis and everything. Okay, so likewise here in that engine also we will be trying to balance something, or how the energy here, the main input and output will be the, or we will be considering as the heat energy or the heat value. Okay, so can you please tell me what will be the expenditure, or in what form this particular energy is giving to the engine? For example, uh, they consider this as an engine. Okay, engine. So there will be so many losses. Okay, losses of that particular heat energy. Okay, like exhaust. Okay, and so many is there. We will be discussing it. But I am asking that what will be the input of this? A input. Okay, something we are giving into the engine. Then only the heat energy will be produced. What will be that? Hello.
Fuel.
Yeah, means the fuel or the heat energy which is given by the combustion of fuel, right? So here we are going to have a balance sheet. Okay, we will be discussing about this. First of all, you just understand what is all this thing. Okay, so here the and energy supplied to the engine. Okay, the energy which is supplied into the engine is the heat value of the fuel, right? So the combustion of that particular fuel is giving us the heat energy, the only source we are getting, right?
Yes, sir.
Yes, sir.
Yeah. So prior to this hour, we were discussing about like the energy that the fuel or the energy which is given by the combustion of the fuel is not purely converted into the useful work. Okay, at the first stage there will be so many losses in the form of exhaust and some several things are there. Then we will be obtaining an indicated power. Then after that the pumping of that particular uh, work will lose so many energy in the form of friction, and then we will be getting a useful work in the form of brake power. Okay, so here the only a sorry, only a part of supplied energy or the energy which is supplied by the fuel is transformed into the useful work, right? Understood.
Yes, sir.
Okay, so the rest of the like that the after the transformation of the particular supplied energy into the useful work, where there will be so many reductions of energies. Okay, some of them will be wasted or some of will be utilized. Can you please tell me an example for the this kind of energy which is utilized? Okay, the rest of it either wasted or utilized in specific applications. Are you getting anything from this sentence? Yeah. Hello.
Yes, sir.
Understood. SF,
Yes, sir.
Karthik. Yeah. Do you understand my question?
Okay.
Yeah. Okay. So my question is that there will be so many losses, right? From the after the combustion of fuel, the energy is produced in the combustion chamber. From there will be so many losses. Okay. So I am asking that whether that particular losses, if we are utilizing that particular losses in any specific application. Karthik. Karthik.
Yes, sir.
Yeah. Do you understand my question? Karthik, I am asking you, do you understand?
Yes, sir.
Then answer പറയടോ.
അറിയില്ല ശരിക്കും.
എടാ, അതായത് ഇതെന്താ ഉദ്ദേശിക്കുന്നതെന്ന് വെച്ചാൽ ഹിയർ നമ്മളെ എഞ്ചിന് ഓക്കെ, ഈ എഞ്ചിന് എന്തുണ്ട്, ആദ്യം എന്താ സംഭവിക്കുന്നത്, ഫ്യൂവൽ വരും. ഫ്യൂവൽ വന്നിട്ട് എന്ത് ചെയ്യും, അത് കമ്പസ് ചെയ്തിട്ട് നമുക്ക് ഹീറ്റ് എനർജി തരും. ആ ഹീറ്റ് എനർജി എന്താണ് പിസ്റ്റണിലേക്ക് ആക്ട് ചെയ്തിട്ട് അല്ലെ, ആ ഒരു പെർട്ടിക്കുലർ ആ ഒരു ഹീറ്റ് എനർജി എന്ത് ചെയ്യുക, ഈ ഫ്യൂവല് ഫോർ എക്സാമ്പിൾ ഇപ്പോൾ ഫ്യൂവല് ബേൺ ചെയ്തിട്ട് നമുക്കൊരു 100 യൂണിറ്റ് എനർജി എന്ന് നമുക്ക് ബാക്കി യൂണിറ്റ് എന്ന് മാത്രം പറഞ്ഞാൽ മതി. ഓക്കെ, 100 യൂണിറ്റ് ഓഫ് എനർജി ഈസ് പ്രൊഡ്യൂസ്ഡ്. ബട്ട് പിന്നെ എന്താണ് നമുക്ക് വരുന്നത്, ഇൻഡിക്കേറ്റഡ് പവർ ആണ്. അത് 100 കിട്ടില്ല. ഓക്കെ, ദർ വിൽ ബി സോ മെനി ലോസസ്. ഓക്കെ, ഫസ്റ്റ് വരുന്ന ലോസസ് എന്തൊക്കെയായിരുന്നു, എക്സോസ്റ്റ്. ഇത് ഓർമ്മയുണ്ടാവും നിങ്ങൾക്ക്, എത്ര പ്രാവശ്യം പറയണം നിങ്ങളോട്. ഡു യു റിമെമ്പർ ദിസ്?
Yes, sir.
എന്തിനു പറയുമ്പോൾ യെസ് യെസ് പറഞ്ഞാൽ മതി കേട്ടോ, ഒന്നും പഠിക്കണ്ട. ഓക്കെ, സോ ഹിയർ വാട്ട് ഹാപ്പൺ, ദ എനർജി ഇൻ ദി ഫ്യൂവൽ അല്ലെ, അതാണ് നമ്മുടെ എന്താ ഒരു ഫോർ എക്സാമ്പിൾ ഇറ്റ് ഈസ് 100 യൂണിറ്റ്. ഓക്കെ, ദിസ് പർട്ടിക്കുലർ എനർജി ഡ്യൂ ടു ദ കമ്പസ്റ്റൻ ഓഫ് fuel we will be obtained as 100 unit. Okay, then from this 100 unit a part of we can just either logical just for understanding 60 units is converted into the indicated power. Okay, the rest will be loss in the form of exhaust, coolant and radiation. Okay, we will be having a discussion over these three things. Okay, so then indicated power, then there will be here from here the what happened, the displacement or the motion of the particular parts happened. As a result, what happened, the frictional loss as well as the pumping and unaccounted loss happens. Okay, we will be discussing about this particular unaccounted also. Okay, then we will be, after that particular losses, we will be obtaining the brake power. Okay, this is the thing. So I am here, my question is here, here they are telling that this 100 unit is not converted into, that full 100 unit is not converted into the useful work. Okay, is not converted into the useful fund. Some of them are losses in the form of exhaust, coolant, and radiation. Okay, so my question is now here. So here the rest of is it either wasted or utilized. Okay, either or utilized in specific application. Can you please tell me? Mainly, we can say we can take in account with these all three things. Okay, here this, if is there is any application of this particular, or if you are utilizing this exhaust energy for any other applications. Yes, it is used for turbo turbo.
Charge.
Yeah, that's what. Similarly, അതാണ് അതായിരുന്നു ഉത്തരം വേണ്ടത്. Okay, okay, fine. So it is used in the in specific applications like the turbocharger and everything. Okay, so here, so the two main parts of heat not available for the work are heat carried away by the exhaust gas as well as the cooling medium. Cooling medium means we will be we will be circulating some water or other coolant in order to reduce the temperature. Okay, so that they will be absorbing some heat energy. Okay, so now we are going to study, or we are going to understand a flow diagram, or a diagram in which what all energy is obtaining into, or it is given into the engine as well as coming out. Okay, so this is that particular flow chart. Okay, so here the main prior thing is that what fuel and air. That means this is giving us the energy. Okay, so and there will be the loss in the form of exhaust gases. Okay, and the cooling water will be given, and they will be taking out some of the heat energy. Okay, and the lubricating oil will be given, as well as it will be taking out some amount of heat energy. Okay, and there will be the crank and the radiation. Okay, radiation, crankcase and wall radiation, which will be taken place after the from the indicated power to the conversion of brake power. There will be, at that time there will be so many losses, and the one of the losses causing there is the crankcase and wall, or the radiation particularly, we can say like that. Do you understand?
Sir.
Yes.
Okay, so yeah, so here we are considering what all factors, or what are the energy which is coming in, and what are the energy which is going out. Okay, so this is the factors which are taking out the heat energy from the, or giving means the fuel, except that others are taking out the heat energy inside the engine. Okay, so here we are not, or we are neglecting this lubricating oil, because lubricating oil, or the heat energy which is absorbed by the lubricating oil, because it is very very minute, or it is very very small, very very small, very very small. Okay, so compared to the heat energy which is absorbed by the cooling or which is taken away by the exhaust gas, here the lubricating oil we are not considering that. Okay, so here we have to understand what. Okay, for example, here we are giving this particular fuel is giving 100 percentage of energy. Okay, so few of the some percentage of the energy will be taken by the cooling water, sorry, then the exhaust will be taking some percentage of the heat, and some will be lost in the form of radiation. So for all this we will be having a income expenditure, like that we will be having a table by which we will be a table like this. Okay, then we will be having a credit debit, and we will be having how what is the what is the value of a particular, and then the conversion in the percentage, and we will be doing like this. Okay, this is the heat balance thing. Do you understand?
Yes, sir.
Yes, sir.
Okay. Okay, so for that, here first we have to understand that the income or the energy is given in the form of fuel, right? Not in the form of fuel, energy is produced or which is given by the fuel. Okay, and that heat supplied by the fuel. Okay, the heat supplied by the fuel, heat supplied by the fuel will be given by the formula. What is the formula?
What I think is
Mass flow rate of the fuel into calorific value. Okay, we already know that. Okay, so this is our credit actually. Okay, this much amount of energy we will be produced. Okay, then what the heat absorbed in the break power production, or while the heat is absorbed or heat is utilized in order to obtain that particular power output. Here the power output is, we already know, break power, so we will be considering like that. So we will denote it by QBP, as well as I forgot to say here the heat supplied by the fuel is denoted by QS. Okay, so here the BP can be measured by loading the engine. Okay, so like that we will be having this particular formula, and we will be finding that particular energy absorption. Okay, and next one will be the heat rejected by the cooling water. Heat rejected by the cooling water, that is denoted by WQ, and is equal to mass flow rate of the cooling water into specific heat of cooling water into the difference between the inlet and outlet temperature of the cooling water. Understood?
yes, sir.
Okay, so next we will be carrying out the heat carried by the exhaust gas. Heat carried by the exhaust gas. Okay, so here the same thing is there. Here the QG, it is denoted by QG. Okay, and which will be equal to the mass flow rate of the exhaust gas into specific heat of the exhaust gas into the outlet temperature of the exhaust gas minus the TA. TA means the ambient temperature, or we will can room temperature. Okay, this is the thing. And here is some one more term is known as unaccounted heat loss. Unaccounted heat loss. Okay, so we can find it as, and it is denoted by QUA, which is equal to the total heat energy supplied, that will be QS. Okay, QS minus other heat energy, that is heat energy loss, that is the heat absorbed in BP and the heat rejected in the cooling water, as well as the heat carried by the exhaust gas. Okay, understood?
Sir.
Yes, sir.
Okay, so this is the thing. Okay, ഇതാണ് this is the procedure, or if you are asked to write the procedure, or you I think you already know this. Okay, so this is the simple method for finding the, or method for finding the, or understanding the what are the losses and the consumption of a particular heat energy or energy of a particular engine. Okay, so this is the thing. Okay, so this is the question. We can discuss it after discussing the retardation test also. Okay. So next and our final topic in the third module is retardation test. Okay, so here there will be question like the write a short note on the performance of the testing of performance testing of a IC engine. So you have to answer all these three. Okay, it may be asked, or similarly there will be the question which will be coming from the Mosters as well as the heat balance. Yes, okay, so retardation test is used to find what? Retardation test is used to find the frictional power, which is used to. So Mosters is used for what?
Indicate.
Yeah, indicated power എന്ന് മാത്രം പറഞ്ഞാൽ പോരാ. Indicated power of what? Indicated power of a power of indicated power of ഓരോ പ്രാവശ്യം ഞാൻ പേര് വിളിക്കാനാക്കണം. എന്താണ് ഫത്തേ? ഫത്തേ പറയൂ, എന്തായിരുന്നു മോസ്റ്റേഴ്സിൽ നമ്മൾ കണ്ടുപിടിക്കുന്നത്? ഹലോ ഫത്തേ,
ഫ്രിക്ഷൻ പവർ ഓഫ് മൾട്ടി സിലിണ്ടർ.
ഫ്രിക്ഷണൽ പവർ അല്ലടാ അസഫ, എന്താണ്? ഓ,
ഇൻഡിക്കേറ്റ് പവർ, ബ്രേക്ക് പവർ.
ബ്രേക്ക് പവർ കണ്ടുപിടിക്കുന്നില്ല നമ്മൾ. ആക്ച്വലി വി ആർ ഫൈൻഡിങ് ദി look here we are finding the indicated power of each cylinder of a multi-cylinder engine. Okay, indicated power of each cylinder, okay, of a multi-cylinder engine. or അതിന്റെ ഓരോ സിലിണ്ടറിൽ ഉണ്ടാകുന്ന ഇൻഡിക്കേറ്റഡ് പവർ ആണ്, അല്ലെങ്കിൽ നമ്മൾ ടോട്ടൽ ഇൻഡിക്കേറ്റഡ് പവറും കാണാൻ പറ്റും അതുവഴി. Okay, so here there are retardation tests which is used to find out the frictional power or friction power of the engine. Okay, which is very simple. Actually, you already, I think you already done this, right? Your experimental undo ningalude lab.
Yes, sir.
Okay, so I think it will be very simple for you. So here retardation test involves the method of retarding. What is meant by retarding?
സ്പീഡ് കുറക്കുക.
Yeah, very good, very good. The decreasing the speed. Okay, the method of retarding the engine by cutting the fuel supply. Okay, so we will be acute or we will be decreasing the particular speed of the engine by the cutting of the fuel supply. We will be cutting the fuel supply and we will be conducting that. Okay, so here first of all we will be doing this experiment. Okay, the engine must be in the no load condition and we will be allowed it in the rated speed. Okay, rated speed la no load condition lana nammal ആദ്യം എന്ത് ചെയ്യുക, ഈ ഒരു പ്രോസസ്സ് അല്ലെങ്കിൽ ഈ ഒരു ടെസ്റ്റ് നമ്മൾ കണ്ടക്ട് ചെയ്യാം. Okay, so for understanding we can just take the rated speed as 1000 rpm. Okay, we are taking the rated speed as 1000 rpm. Okay, okay,
Yes, sir.
okay, so then we will be like allowing a few minutes. Okay, for the idling and everything we will be allowing for the engine for a few minutes. Okay, then for the steady conditions, okay, we will be cutting off the supply of the cylinder, sorry, cutting off the supply of the fuel. Okay, then we will be taking the time to fall in the speed by the 20, 40, 60 and 80 of the rated speed. Okay, that means simply, okay, so first of all we are allowed to reach in the rated speed, right? So then what will happen? We will cut the fuel. We will be cutting the fuel. Okay, then we will be start taking the time till the speed of that particular engine reaches a 20% reduction in the rated speed. മനസ്സിലായോ?
Yes, sir.
ഓക്കെ, അതായത് 1000 എന്നല്ല. യാ, അണ്ടർസ്റ്റുഡ്. ഇപ്പൊ ലാസ്റ്റ് പറഞ്ഞത് ഡൗട്ട് ഉണ്ട് എന്നാണോ അല്ല എന്നാണോ? ഓക്കെ ആണോ? ഷാൽ ഐ കണ്ടിന്യൂ?
Also,
ഓക്കെ ഓക്കെ ഓക്കെ. സോ എന്താണ് നമ്മുടെ ഈ അല്ലെ 1000 ആയിരുന്നു നമ്മുടെ ആ ഒരു റേറ്റഡ് സ്പീഡ് വരുന്നത്. അല്ല, ആ 1000 നിന്ന് എന്താണ് 20% റിഡക്ഷന് വേണ്ടിയുള്ള ടൈം നമ്മൾ എന്ത് ചെയ്തു? നമ്മൾ എടുത്തു. ഓക്കെ, നമ്മൾ ഫോർ എക്സാമ്പിൾ ലെറ്റ് ഇറ്റ് ബി എക്സ്, സോറി, let it be x seconds. Okay, after that again we will be taking this particular engine into 1000 rated speed again. Just 1 minute. Okay. Oh. Can you hear? Can you hear? Okay.
Yes, sir.
So here, first of all, we will be allowed that particular thing into the 100 RPM, and we will be cutting off the fuel. Then till it reaches, or the reduction of that particular speed reaches the 20% of the rated RPM. Till that, we will be taking the time. Okay. Then again, what will we will be again taken that particular engine into the rated speed again. Okay, then from that again we will be cutting the fuel, and again we will be taking the time till the 40% of the reduction, or sorry, 60 RPM, 40% of the reduction, and we will be getting another time. Okay, let it be T2 and this one equal to T1. Okay, similarly till that will be like 20, 40 and 60 and 80% reduction in the rated speed. Okay, this much time we will be taking T1, T2, T3, T4. Understood?
Yes, sir.
Okay, here we are taking in the no load condition. Okay, no load condition. Next we will be taking, or we will be carried out the same procedure at a 50% load. Okay, 50% load, we will be taking the particular T1, T2, T3 and T4. Understood?
yes, sir.
Okay.
Yes.
So after, so here we will be taking two values, right? Drop in speed and the time for the drop in speed. Okay, so then we will be going, or we will be drawing a particular graph in which this particular quantity will be taken in the x-axis, and this will be taken in the, sorry, it will be taken in the y-axis, and the time for the particular drop in speed is taken in the x-axis. Okay, so here the test is sorry, yeah, the graph connecting the drop in the speed is taken in the y, and the time for the drop in the speed is taken in the x-axis, and at a no load as well as the 50% load condition is drawn. Okay, so we will be drawing this particular graph. Okay, taking the x and y axis. Understood?
Yes, sir.
Okay, so we will be getting we will be getting a graph like this. Okay, we will be getting a graph like this. From this graph, for a 100 RPM. Okay, 100 RPM. So this is the speed and this is the time. Okay, this is the drop in speed as well as this is the time. So here we will be getting two lines in the for the 50% load as well as in the no load condition. Okay, so we will be taking a 100 RPM. Okay, 100 RPM. Okay, So we will be getting, or we will be taking the time for that particular 100 rpm from the no load condition as well as the 50% load condition. Okay, time required to fall. Okay, do you understand?
Yes, sir.
അതായത് ഒരു 100 RPM കുറയാൻ വേണ്ടുന്ന ടൈം നമ്മൾ എടുക്കും ഫ്രം ദി നോ ലോഡ് ഗ്രാഫ് ആസ് വെൽ ആസ് ഫ്രം ദ 50 ലോഡ് ഗ്രാഫ്. അണ്ടർസ്റ്റുഡ്? Okay, and this particular no load condition, we are denoting that particular time as T2 and here the time as T3. Okay, T2 and T3. Okay, so then we have a formula for the frictional torque as Tf equal to TL into T3 divided by T2 minus T3. Okay, here the TL is nothing but the load torque or the torque of corresponding load. Okay, our corresponding load lulla torque. Okay, from this equation we will be able to find the frictional or friction torque. Okay, so and by substituting that particular Tf in the frictional power or this formula, we will be obtaining the frictional power. Understood? We will be obtaining the frictional power. Okay, ഇതിൻ്റെ അകത്തുനിന്ന് ക്വസ്റ്റ്യൻ അങ്ങനെ ഇതുവരെ വന്ന് കണ്ടിട്ടില്ല. Let me check once more. Okay, this is a procedure for that. Understood?
Yes, sir.
Okay, so this is the thing. Okay, so we can discuss this particular problem. Okay, you can take a screenshot and you have to copy down and you have to try to solve this particular thing. And once we are there in the college, you have to submit that particular thing. Okay, understood?
Yes, sir.
Yes, sir.
Okay, so ഇവിടെ എന്താ പറഞ്ഞിരിക്കുന്നത്? In a test of single cylinder diesel engine, the following data were observed. Draw the energy balance sheet. Load on the breakdown is 10 kilogram. Okay, radius of breakdown is 21 centimeter. Speed equal to 850 rpm. Okay, then fuel consumption is 0.670 kilogram per hour. Okay, ഇവിടെ അവറാണ് തന്നിട്ടുള്ളത്. സോ നമ്മൾ എന്ത് ചെയ്യണം? എപ്പോഴും കണ്ടപ്പോൾ തന്നെ ഓർമ്മിച്ച് വെച്ചോ. എന്താണ് നമ്മളത് കിലോഗ്രാം പെർ സെക്കൻഡിലേക്ക് നമ്മൾ കൺവേർട്ട് ചെയ്യണം. ഓക്കെ, ദെൻ ദ കലോറിഫിക് വാല്യൂ ഓഫ് ഫ്യൂവൽ, ഓക്കെ, വിച്ച് ഈസ് ഗിവൺ ആസ് 44,000 അല്ലേ? അതെ, 44,000 കിലോ ജൂൾ പെർ കിലോഗ്രാം. എയർ കൺസപ്ഷൻ 43, കൂളിംഗ് വാട്ടർ റൈസ് ഇൻ ദ ടെമ്പറേച്ചർ 15 അല്ലേ? അപ്പോൾ എന്താണ് നമുക്ക് അവിടെ ചേഞ്ച് ഇൻ ടെമ്പറേച്ചർ തന്നെ തന്നിട്ടുണ്ട്. ഓക്കെ, സോ വി ക്യാൻ ടേക്ക് ഇറ്റ് ആസ്, അതായത് വി ഡോണ്ട് നീഡ് ടു ടേക്ക് ദാറ്റ് ഇൻലെറ്റ് ആൻഡ് ഔട്ട്ലെറ്റ്. Okay, here it is given directly as delta T. Okay, exhaust gas temperature as 325 degrees Celsius. Cp of gas is 1.115 kilogram per kilojoule per kilogram Kelvin, and room temperature or the ambient TA equal to 34 degrees Celsius, and the mass flow rate of cooling water equal to 97.68 kilogram per hour. Okay, so this is the question. So first of all, you like we all know that you have to study this all these equations, and it is very simple for you also. We already know that this particular mass flow rate into flow, and just go through this and we will be getting that equation. Okay, by heart പഠിക്കണ്ട, മനസ്സിലാക്കി പഠിച്ചാൽ മതി. So okay, using these terms we can write this like given data as എന്താണ് WS ഈക്വൽ ടു 10 കിലോഗ്രാം. ഓക്കെ, WS എന്ന് വെച്ചാൽ നമ്മൾ ഈ ഒരു റേറ്റഡ് സ്പീഡ് ടോർക്കെല്ലാം കാണുന്ന സമയത്ത് നമ്മൾ ആ ഒരു ഫോർമുല യൂസ് ചെയ്തിട്ടുണ്ടാവും. ദ ലോഡ് ഓൺ ദ ബ്രേക്ക് ഡൗൺ ആണ് എന്ത് ഈ ഒരു 10 kilogram എന്ന് പറഞ്ഞത്. ഓക്കെ, സോ ദെൻ ആർ ഈക്വൽ ടു 21 ആൻഡ് ആ തന്ന വാല്യൂസ് എല്ലാം എന്താ ഇവിടെയാണ് എഴുതുക. ഓക്കെ, ഫോർ എവറി ക്വസ്റ്റ്യൻ യു ഹാവ് ടു റൈറ്റ് ലൈക്ക് ദിസ് ദ ഗിവൻ ഡാറ്റ. ഓക്കെ, ഇതൊന്നും എഴുതിയ ഫസ്റ്റ് സീരീസിലൊന്നും കണ്ടിട്ടില്ല, അതുകൊണ്ടാണ് പറയുന്നത്. ഓക്കെ, ഇറ്റ് ഈസ് വെരി ക്വൈറ്റ് നോർമൽ ഫോർ റൈറ്റിംഗ് ഓൾ ദീസ് തിങ്സ്. ഓക്കെ, so first of all we can find the heat supplied by the fuel. Okay, we can discuss it later. Heat supplied by the fuel. Okay, so it will be, or the formula for is Qs equal to mass flow rate of fuel into calorific value. Okay, so here the mass flow rate is given. Okay, mass flow rate is the fuel consumption is 0.670 kilogram per hour. So in order to convert it into the second, we will be dividing it with the 3600 into calorific value. Okay, calorific value means here the calorific value is here. Okay, straight away we get this 8.19 kilowatt. Okay, so what is this? Actually this is the total energy which is available in the engine, right? Alle?
Yes, sir.
Okay, so next we will be finding the brake power. Okay, brake power എന്താണ് അല്ലേ? എന്താണ്? The formula equal to 2 pi n t divided by 60 ആണ്. Okay, here the torque എന്ന് വെച്ചാൽ എന്താണ്? In the case of this, what will be the torque? എന്താണ് ടോർക്ക് എന്ന് പറഞ്ഞാൽ ലോഡ് ഇൻറ്റു റേഡിയസ് അല്ലേ? Okay, this load is given as ws equal to 10 kilogram, and the radius is given as how much? 21 centimeter, right? So here we will be substituting the 2 pi and n is given as 850 rpm. Okay, n is given as 850 rpm into 10 into 0.21 divided by 60. Can you please tell me why we are adding this particular 9.8? എന്തിനാണ് 9.8 ചെയ്യുന്നത്? ആ പറയൂ, അതെന്തിനാ അത് ചെയ്യുന്നത്? എന്താ സഫേ? ഹലോ, ക്ലിയർ ആകുന്നില്ല മോനെ. മാസ് ആയതുകൊണ്ട് എന്നാണോ പറയുന്നത്? ഓക്കെ, എന്താണ് ഹിയർ ദ ലോഡ് അല്ലെ? ലോഡ് ഈസ് ഗിവൺ ഇൻ എന്താണ്? കിലോഗ്രാം അല്ലെ? സോ ഇറ്റ് മസ്റ്റ് ബി കൺവേർട്ടഡ് ഇൻ ടു ന്യൂട്ടൺ അല്ലെ? കിലോഗ്രാമിന് എന്ത് വേണം നമ്മൾ? വി ഹാവ് ടു കൺവേർട്ട് ഇറ്റ് ഇൻ ടു ന്യൂട്ടൺ. ഫോർ ദാറ്റ് വി ആർ multiplying with the 9.81. Okay, so we will be getting a value, or we will getting a value as 1.83 kilowatt for the brake power. Okay, we'll be getting the value for the brake power. Okay, so here namaka value one in the like here we need the value as much like that. Also we have to understand the total, from this total percentage of the energy, how much energy is utilized for this particular BP production. അല്ലെങ്കിൽ എന്താണ് ആ ബി പിയിലേക്ക് എത്ര എനർജി പോയിട്ടുണ്ട് എന്നുള്ളത് പെർസെൻറ്റേജ് കൂടി നമ്മൾ കൺവേർട്ട് ചെയ്യണം. സോ ദാറ്റ് ഹിയർ the available energy is what? 8.9, right? Okay, so and the BP production or the heat supplied by the the brake power is 1.83. Okay, so converting it to the percentage, we will be getting that 22.34%, right? Understood? Total energy എത്രയാണ്? ഇത്രയാണ് അല്ലേ? അതിൻ്റെ എത്ര പെർസെൻറ്റേജ് ആണെന്ന് നമ്മൾ ഈ ഒരു ബ്രേക്ക് പവർ ഉള്ളത് എന്ന് മനസ്സിലാക്കുക. ഓക്കെ, understood? Okay, so similarly here the heat taken by the cooling water, it is denoted by QW. Okay, then what was that? M എന്തായിരുന്നു? MW പറയൂ. the mass flow rate of the cooling water. Again, it is given in the hour. So we have to convert it into the second. So we will be dividing with the 3600, and CW for the particular thing is given as 4.4. Okay. Yeah. Okay. Then what? The change in thing is given here. 15. Okay, 15. So we will be getting the value for 1.71 kilowatt. Okay, so we will be converting that particular into the percentage. We will be getting a percentage as 20.88. Okay, similarly here that heat taken by the exhaust equal to the mass flow rate of gas into Cg into Tg minus Ta. Okay, here we are taking that particular here and then mg, the value of mg. Okay, but instead of that, here in the exhaust gas, okay, you can think like that. Exhaust gas mass flow rate, fuel unburned down, but we are not considering that. Here we are considering only the mass flow rate of the air. Okay, we can directly write that particular MA here, and we have to convert it into the
Sir, charge or
okay, we will be converting that. Okay, ഇവിടെ എന്താണ് ആ ഒരു TG തന്നിട്ടുണ്ട്. Okay, ambient temperature, room temperature 34 ആണ്. അവിടെ rising temperature എത്രയാണെന്ന് തന്നിട്ടുണ്ട്. So we will be substituting this formula and we will be getting 3.91 kilowatt. Okay, അത് നമ്മൾ പെർസെൻറ്റേജ് കൺവേർട്ട് ചെയ്തു. ഇവിടെ കണ്ടോ നിങ്ങൾ ഏറ്റവും കൂടുതൽ നമുക്ക് ആ പുറത്തേക്ക് പോകുന്നത് ഇൻ ദ ഫോം ഓഫ് എക്സോസ്റ്റ് ഗ്യാസ് ആണ്. ഓക്കെ, സോ എക്സോസ്റ്റ് ഗ്യാസിലാണ് പോകുന്നത്. ഓക്കെ, ജസ്റ്റ് കീപ് ഇൻ മൈൻഡ് അബൌട്ട് ദ ടർബോ ചാർജർ. Okay, so next the uncountable. Okay, the unaccountable. Okay, it is a very simple thing. എന്താണ് നമ്മുടെ ആ ടോട്ടൽ അല്ലെ, എന്താണ് ആ ടോട്ടൽ എന്താ ഇതുവരെ നമ്മൾ കണ്ടുപിടിച്ച 1 2 3 sorry, these three things. If we are subtracting that particular from this, we will getting the unaccountable heat losses. Okay, so we will get a percentage of 9.04. Okay, then you can just draw this table and you can write like this, the credit and debit and the values as well as in the values in the percentage. Okay, then we will be ready with the heat balance sheet. Understood?
Yes, sir.
Okay, so ഇത് ഇന്ന് തന്നെ ചെയ്ത് നോക്കണം. ഫസ്റ്റ് ഓഫ് ഓൾ ഇതൊന്ന് സ്ക്രീൻഷോട്ട് എടുത്ത് വെച്ച് ഡൺ.
Sir.
This also.
Sir, 100% charge.
എത്ര ആരാ റോൾ നമ്പർ ആരാ പ്രസന്റ്?
Roll number 9.
ഓക്കെ ഫൈൻ.
സർ 10%.
അവിടെ ഒരു മിനിറ്റ് എല്ലാവരും പറഞ്ഞാൽ ഇതേപോലെ പറയും. 10. ഓക്കെ, ഇനി ആരും പറയല്ലേ, ഇപ്പൊ ശരിയാക്കാം. കഴിഞ്ഞു, വി ആർ ക്ലോസിംഗ്. ഓക്കെ.